cars, so it's the superimposition of all transport together. It's perfect. This is the drop-off area where you enter the car and you can meet your friends. Then what is interesting is that the train is coming every 1.5 minutes, and daily frequency of passengers is 150,000 people. So you can get always every time different looks or atmosphere from the movie. This is the upper platform for high-speed trains.
I'm the second group from Rashid studio. I'm from a studio project, so we started last term as a group of 3 guys, and in this semester we are still continuing the project, so it's a sort of work in progress situation. Generally the task in the Rashid studio is called Deep Future City, and it's this task since Hani is here, and a year ago there was a master plan, and now this year we are doing expo pavilions. So the idea is that you start developing a city not by a master plan, but by organizing an expo show where pavilions demonstrate certain principles concerning the deep future city, as new ways of transportation, new systems of healthcare, food production, and so on. And every group chooses its own topic, and as a common task there was a warm-up task which started with the truncated octahedron, which is Archimedean solid, and we use this truncated octahedron to organize the master plan of this expo show. So our first idea about the object was the Hamilton loop, which we found out. So you can see it on the very left. The Hamilton loop connects all vertices of the object, and which is interesting. On the other hand, it's a connection, but it's also a division of the surface of the object, which you can see on the unrolled side. And can you please click into the right side? No? Back. Click. Oh, sorry. There should be an animation. No, in the PDF there should be the animation. Does it not work? Could you? So sorry, because it's very important that these videos work, because they show how the how we generated this form, but just as a very abstract, the idea was that this matrix is very rigid, and we wanted to work with this matrix and bring a certain type of continuity into the matrix. And yeah, this one, and the warm-up, yeah, and also the other two, please. So the Hamilton loop, and then we made a volumetric loop. We then smooth the interior, which gets back the loop also as a border between the inside and the outside. And then we introduced another loop as this crease in the smooth interior. unfortunately you cannot see it so good, but you have 3 zones now and the unrolled version, and when it's folded back, yeah, it's this object again. So now presentation. Back. So this is the object I was talking about. So again, the main rules: you have the exterior Hamilton loop, and you have this smooth interior loop, and you have these blue connecting loops. And another thing is that the object has an open and a closed side. Next. Okay, which you can also see, for example, the relationship between the interior and the exterior loop. You can see on the very top right, there is the red interior loop, which is almost at the outside of the object, and at the center, on the open side, the loop is almost in the center of the object. And this was the first outcome of the object, so the single object, and we then further continued with extending the repertoire of the messing by developing with the same rules 2 more objects. And what we further also introduced was a kind of orientation planes which guide this curve in the interior. And it was very important because as we then worked with the configuration of 3 of the objects, the idea was that now every object has its own interior loop, but there is also a common overall loop which connects all of them. So we were interested in how the relations would change if they sit beside each other, and these are the first outcomes of these relations. As you can see in this example, that the neighbor is reacting to the neighbor, so the smooth loop is reacting to the polygonal loop. Click on this. Oh, sorry. It's the massing. It's just an overview about the 3 objects to understand them better. Presentation again. Yeah. And now this is the site. So this is our area, and we developed, so each group has a certain area on the site. There will be a large wall which is a 60-degree inclined plane, and it's divided into 9 areas. And at the end of this semester there will be a large model which will be the presentation for the finals. And we designed the site by pixelating it. So we started with from the largest scale of octahedrons to a very small scale, and we have these 3 main cuts, as you can see in the top left, which sort of define the main directions for approaching to our octahedrons or to our pavilions. And as you can see here, our topic our programmatic topic is new ways of transportation, and we are still in a very abstract phase for working on that, but the idea is that you have these lines which get you at the border of your site, and they bring you to the center, and there you have this crazy 3-dimensional curved surface where you move on with a cell, and this is this one continuous surface. And we are very interested in different kind of sections and how you would perceive the building through the circulation. So it's more about perceiving the object through circulation. This is the main focus. Now the animation, please. And this was also the goal for midterm, that we try to do animation to show certain sequences of the building, like how we move from the distance. Yeah, that's it.